In speaking with different students, I've found that a lot of times on the praxis they've had trouble with probability. So we're going to introduce probability in this video, and then we'll go on to look at it in more detail. So just to show you where they are in the standards, statistics and probability here in the grades 6 through 8 standards. Now, you may not be teaching middle school, but as you start talking about fractions and parts of a whole, you can work in some probability and some statistics. So, interpreting probability. So what does probability mean? So, probability itself is the mathematics of chance. So, if we had an example, the chances of winning the lottery are 1 in 150,000. Okay, then only one of every 150,000 lottery tickets will be a winning ticket, which is very slim, right? That you get a winning ticket. So, some terminology we need to begin with is what we term as an experiment. So this is an investigation or a procedure that has varying results. So it could be tossing a coin. It could be rolling a dice. It could be asking someone how many pets they have, so you can get different outcomes. That's the word I just mentioned, outcome. So these are all the possible results of an experiment. If I were to toss a coin, the possible results would be, if it's a fair coin, a head or a tail, and we're not going to consider right now that it might land on its side. If you are playing a dice game, then if you toss a die, you could come out with, if it's a six-sided die, you could come out with the values 1, 2, 3, 4, 5, 6. Those are all the possible outcomes. You could come out with values that are odd or even. Those are also possible outcomes. Now, the outcomes of a specific event that you're looking at are called favorable outcomes. Favorable outcomes do not mean that it's something you want to happen. Okay, so if you want to toss a head, but you're looking at the probability of tossing tails, the favorable outcome when you're counting the probabilities is the one you're interested in. If you want the probability of having your identity stolen, okay, that's not favorable to have it done, but because that's what you're looking at, then that is your favorable outcome. And an event is any collection of possible outcomes for a particular experiment. So here's an example. We have a number cube with the sides that are labeled 1, 2, 3, 4, all the way through 6. So we want to know, what are the possible outcomes? Well, if you toss this thing, you could come up with a 1, a 2, a 3, a 4, a 5, or a 6. I'm going to put that in a set because we usually look at sets of outcomes. What are the number of favorable outcomes of rolling an even number? So I want to look at how many of these outcomes are even, and what are they? Well, 2, 4, and 6. Those are the favorable outcomes of rolling an even number. And the last one, what is the favorable outcomes? What are the favorable outcomes of rolling a number greater than, and this should be a 4. Well, which of these numbers are greater than 4? And we can't include 4. So you need to look for words like greater than or equal to, at least, things like that. So only 5 and 6 are the favorable outcomes for rolling a number greater than 4. Now when you do work with percents, especially in financial stuff, you can have like 200% profit. In fact, you want to have more than 100% profit because that means you earn more than you invested. So you are actually making a profit. But when it comes to probability, the values have to range from 0, where it's impossible, all the way up to 100%, where it's going to happen. So when we have probabilities, if someone gives you a negative probability, that can't be correct. Or if someone says, well, there's a 110% chance of rain today, that's impossible. 100% means it's certain. 0% means it's impossible. And then somewhere between here is where it will occur. So it could be unlikely to occur, about 25%, 50%, equally likely to happen as not to happen, and then likely, around 75%, and higher the more likely you get as you go towards 100%. So one way to find a probability of an event is to conduct a series of experiments. So experimental probability is the relative frequency with which an event occurs in a particular sequence of trials. By relative frequency, we're talking about percents or a fraction of those numbers, a fraction of those trials, in that particular experiment. Okay, so here someone tossed 2 coins 500 times in a row, and these are the results. They had head 137 times, head tail 115 times, tail head 108 times, and tail 140 times. So they have a total of 500 trials. So now we're going to find the probability by finding the relative frequency. So I take the frequency divided by the total, and this is the probability that I got, or they got head. This is the probability they found for getting head tail. This is the probability for getting tail head, and this is the probability for getting tail. So we know if we can express something as a fraction, we can also change that to a percent. But these are all the possible outcomes. So their probability should add up to 1 or 100% if we're looking at the percentages. Okay. So now look at this one. Let E be the event of getting a head on the first coin and find the experimental probability of E. So the probability of getting a head on the first coin is, together I have 137 plus 115, which is 252 out of 500. I think I left out earlier in the slides some notation we talk about. If E is an event, then the probability of an event occurring is written like this. And I usually, instead of P of E, I'll put what the actual event is that I'm looking at. So that's if we actually run an experiment. But suppose we know all the outcomes already. So we should be able to tell what should happen. So instead of conducting experiments, we use theoretical probability. So the theoretical probability is the chance that an event will occur based on the situation, and knowing how the outcomes should occur, like a coin. If it's a fair coin, you should get 50% chance for heads, 50% chance for tails. Now, if all the outcomes in a sample space are equally likely to occur, then I find the probability the same way. I take the number of outcomes in the sample space and the number of outcomes in the event, and then I divide those. And again, here is the notation for the probability of an event occurring. Then we have the event of getting a head on the first coin. So the probability of getting an event, getting a head, sorry, is the probability of getting a head or a head tail. And in our sample space, these were 2 of the outcomes out of 4, which is 50%. Now, the probability of getting a head either on the first or the second toss would be the probability of these outcomes: head, 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 tail, tail, head. And these are 3 of the 4 possible outcomes, which is 0.75 or 75%. So in this case, I could have added these probabilities together to get 50%, or just simply added these 3 to get 75%. That is only because everything is equally likely and we have divided our outcomes into all different possibilities. We'll look at some other situations where we may not just add the probabilities together. So I'll draw a jar. I usually like to have these things already, pictures of them. So I've got a red, I've got a green, and I've got a blue. So I'm going to draw 2 marbles without replacing the first one. So I could get a red. So this is my sample space, all the different outcomes I can have. And we usually put this in set notation too. I could draw red, and I could draw green. I could draw red, and I could draw blue. I can't draw red because once I pull that red out, I don't have it anymore in there because I'm not replacing it. I could draw green, red. I could draw green and then a blue. Or I could draw a blue and then a red, a blue and then a green. And since we're looking at what happens on the first marble, then the order red-green is not the same thing as green-red. So the first marble being red or yellow, okay, this is my event. It could be red-green, red-blue, because that's where the first marble is red. Okay, now do I have any yellow marbles at all in here? No, I don't. So there are two events that I can use. So the probability of the first draw being red or yellow. How many events do I have like that? 2 out of how many events in the sample space? So it's 1/3. The last kind of probability is subjective probability. And this is probability based on experience, not necessarily numerical evidence, but based on your intuition of what things can happen. Now these could be completely off. They could be close, because if you've gone through, had things happen and you've had it happen several times, so you've had experience with this phenomenon, then you can get an idea of what the subjective probability would be. But these also can be very misleading. And one example is when I think of the probability of my going to a party and winning a door prize. Up until I was about 25, I would say that probability was 0%. In fact, if that was the reason I was going, I wouldn't go. Because I never won anything, just by chance. So, but then after I got older, I actually did go somewhere and win a door prize, and then it kind of seemed frequently. Okay, but if I had stayed with my first opinion that the probability of my getting a door prize was nothing, then I would be wrong, because I was just using the probability from only some of the experience I had had so far, not all of the experience. So these can be, if you're very intuitive, these can be close. If you're not intuitive, these can be very difficult. And when it comes to traditional probability problems like games, chance, things like that, often what seems like it should be is not. So let's do one problem where we compare experimental and theoretical probability. Okay, so you're going to spin this spinner 100 times, and each of these spaces are the same size. Okay, so when you spin it 100 times, you have 38 reds come up, 38 yellows, 31 reds, 19 blues, and 12 whites. So your experimental probability of spinning a yellow, let me change this ink color, is 1 is 38 out of the 100 times, which is 38%. So these are all your experimental probabilities. The probability that you spun a red was 31 out of 100. The probability that you spent a blue was 19 out of 100, or 19%. And the probability that you spun a white was 12 out of 100, or 12%. So those are the experimental probabilities. What about the theoretical? And sometimes you will hear the word classical probability instead of theoretical, but they're the same thing. So now let's look at the theoretical probability. So these are not based on these results here. These are based on knowing what these outcomes are and knowing that each of these wedges is the same size. So the probability of spinning a yellow, I have 4 wedges that are yellow out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 wedges altogether. So that's 40%. Hey, not too bad. The probability of a red, I have 3 of the 10 wedges which are red, so that's 30%. The probability of a blue, I have 2 of the 10 wedges that are blue, which would be 20%. And then the probability of a white, I have 1 out of the 10 wedges, which is 10%. Now, these are not exactly the same, right? So we're looking at these comparisons, are not exactly the same. But it turns out that there's a law called the law of large numbers, and if the more trials you do, okay, so say we actually spun the spinner 500 times, or 600 times, or 700 times, the law of large numbers says that when you start taking more and more trials, you're going to get closer and closer to this theoretical probability. So although I should get a yellow 40% of the time, it could be that I might not get a yellow on the first 50 spins. That's possible. It's possible, but it's not probable. So if I just looked at those spins, I might think, gosh, the probability is 0. But it's actually not. So when we want to calculate probabilities, we want to base them either on experimental or on theoretical. But theoretical is actually what it should be. Experimental is what it happens to be in a certain experiment. And again, the larger the experiment, the more trials, the closer you're going to get to actual theoretical probability.